download it. It's a PowerPoint. You should download it to your computer. And as you do each project part, you should put it on here. So project part 1 was the sampling. Project part 2 was the frequency distribution. Project part 3, measure of center, 5-number summary, standard deviation slides. And then project part 4 is all of that. Project part 5 will be the 90% confidence interval. Project part 6, hypothesis test, and then the actual semester project due at the end of week 14 is the whole thing. So when it comes to the sample, you have to sample properly, otherwise the rest of the stuff is not going to really work, right? So I'm going to go over the sampling method, and if I have time, I'll try to do a little bit of the others. But this is exactly what I did in my videos as well. So you choose a data set, following the instructions, choose a data set from the data sets that are given, which you find here, data sets, pick one, right? Click on it, pick whatever one. Create a systematic sample. You have to obviously know what a systematic sample is. That takes us back to week 1 and the sampling methods. A systematic sampling method is to select a random start, and then you have an nth value, which means you select every nth. So what this is telling you to do is you have to start in row 1, and you use your birth month to determine the column in row 1 that you're starting in. And your birth day will be your nth value. So this is just a way of us getting different samples. So where's my paint? So for example, I pick whatever this is, 2013, blah, whatever it is. My birthday is May 6th. Pencil. So 5/6, that is not. Let me see if this is thicker. Nope. This is too thick. Hold on. Let me. Okay. 5. Come on, paint. I don't like paint, but there. 5/6 is my birthday. The month is May 5, and the day is 6. So I would start in row 1. I just lost my mouse. Where did it go? Okay, yeah, I would start in row 1, and I would start in the 5th column because my birthday is the 5th month. So my first value to go into my sample is 107. So my sample, as I collect, I'm gonna write it out. 107 goes into my sample. Now, because my birthday is 6, my nth value is 6. I would count every 6. So from my first starting point, I would count every 6. 1, 2, 3, 4, 5, 6. That's the next value in my sample. Right? Keep going. 1, 2, 3, 4, 5, 6. Keep going. 1, 2, 3, 4, 5. And put them into your, so my first round is blue. And if you notice, sometimes you get a pattern. If I continue to select every 6th, I'm going to get all these values, right? And all these values that are going to go into my sample. I'm going to list them in my sample. I'm not going to write them down now, but yeah. The problem is, how many do I have? 2, 4, 6, 8, 10, 12, 14, 16, 17 values, and I need 35 values for my sample. So I have to continue. This is called a wraparound method. Now, the problem with this, let me choose a different color to wrap around. The problem if I continue to select every 6 is 1, 2, 3, 4, 5, 6. I'm landing on the same exact values over again, and we want to avoid that. We don't want that kind of repetition. We do not want that kind of repetition. So if you have the situation, now some of you can continue to count and it won't repeat that way. If that's what you have, then good for you. Then do it that way. If not, another method is this example. Here. If Quinn does not, or as an example, if you do not get the 35 required data values and you run out of the table, then you could wrap around this way. If you have repetition, like I just said, the last value, write down the column and row and switch it. What does that mean? My last value here for my blue, let me go back to blue since my last value was 405 and it was in column 5 row 9. So what I'm going to do for my next round, so I don't get repetition, is switch these numbers and go to column 9 and row 5. Row 5, column 9, and then I'm going to continue to do it. Row 5, column 9 is, oops, why is this not working? 654. And I would write that in my sample, and I would keep going every 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I would write down these values. And I would continue to do this until I get 35 total data values for my sample. Okay, if I need to keep doing this. So what is it that the project tells me to do on the template? It says, do your sample, write at least 2 quality sentences explaining, at least 2, which data set you used, what your starting number was, basically how you sampled, so that anybody reading it could obtain the same results. So if I read your explanation as to how you sampled, I should be able to get the same exact sample just by reading what you wrote. If I don't get the same sample by reading what you wrote, then you didn't write it correctly. So I would write, I started in row 1, column 5. That was my starting point. My nth value was 6, so I selected every 6th, and I would type this out. I selected every 6th value, and blue is what, if you want to show it, I like seeing this too because it does help support what you're explaining. And blue represents my first round. I selected every 6th. When I got to the bottom of the table, I only had 17 values and I need 35. So I had to figure out a way to wrap around. How did I wrap around? I took my last value, 405, and that was in column 5, row 9. And then I switched the column and row to give another starting point. So column 9, row 5 was my second round, the green. That was my new starting point, and then I selected every 6th again after that. I continued to do this until I got 35 values. If you guys got to this point where you continued to count using your nth value and did not have the repetition, you would just say, I continued to count every whatever it was, and until I got 35 values. The idea is that you start in row 1, in column whatever, you have an nth value, and you explain how you did it such that anyone reading should be able to recreate your sample. Okay, I don't want the repetition. I don't want the same stuff 20 times. I don't want that repetition. Some of you might get some repetition. A couple values repeating is not a big deal, but the same, look at this. If I were to repeat the same blue over and over again, I don't like that sample. Okay, so you could do this other method to continue to what we call wrap around and continue to sample. But you have to write an explanation so that it makes sense to someone reading it, where they can recreate the sample. And having this population with the colors shown with your explanations help. That's project part 1. That's the first slide. So you're writing it. You can show your population either on this slide, or you can add another slide showing that. That's okay. But write your process and list your 35 values in the order they were collected. That's project part 1. Project part 2 is a frequency distribution table. Notice that your template has 2 slides. One for instructions, which you delete after you use the instructions, and the other one to fill in. These are just the instructions. I don't want this slide. We know what we gave you. Using the 35 values you created for extra credit 1, now you're going to create a frequency distribution of 10 classes. It gives you how you calculate your class width. You need to know, you need to know class width to create a frequency table, if you remember. Take the maximum minus the min over 10. Whatever your max is, whatever your min is. Remember, you round up to the next whole number. So that's important. If you did not round up, I didn't give you points for that. The whole frequency table might be off. You have to round up. Class width, remember what class width? Rules, rounding rules. So you have your class width. You start your lower bound, you can literally type it in here. Enable editing. In your own words, explain. I'll talk about that in a second. Your lower bound will be your minimum value, whatever the heck that is. I'm going to make up a number, whatever it is, 4. I take the lower bound and continue to get my lower bounds using the class width. So imagine the class width was like, class width. I want to see this. You go max, whatever the heck your values are. You guys need to type this in. Let's just assume my class width was like 30. I'm making up numbers. So I would add my class width to each one of these to continue to create my lower bounds. And then your upper bounds is 1 less than the last lower bound. Okay? And you go up to 10 classes. So you are describing, in your own words, explain what you did to fill in each column. You're saying, I calculated my class width first. I want to see the calculation using your values, whatever numbers you have, maximize, show me that. Whatever your class width is, round it up. Tell me what your class, some of you are like writing what you did and not telling me your class width. So that doesn't, what is your class width? What are your values? Say I started my first class and my first lower bound was my minimum value. My minimum value is equal to 4. Then I added my class width of 30 to continue to get my lower bounds. To get my upper bounds, you could do it a couple of ways. You can say, since the class width is 30 and this is inclusive, you know that this should be 1 less than that. However you found your upper bound, there's different ways to do it. This is how I created my classes. How do I find my frequency? I go to my list, my sample, wherever the heck that was, which you should have here. And, you know, I count how many values from my sample are in each of these ranges. So from 4 to 33, how many values were in that? I don't know. Let's just make up numbers. From 34 to 63, how many numbers was there? Blah, 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 right? How do you find your relative frequency? You take the frequency and divide by 35. You should have 35 values and then round. I want to see the sums of these because this should add up to 35 if you have all your values, and this should add up to 1 or be very close if you did everything correctly. That's a quick check. Write all that here. You could write it quickly. Shouldn't take that long. Show me your class width calculation. Class width is equal to this. I started my lower bound for my first class at the minimum. I added my class width to continue to get my lower bounds. I determined my upper bounds because it's 1 less than the next lower bound. I find my frequency by determining how many values are in each class. I determine my relative frequency by taking its corresponding frequency, dividing by 35, and I get the relative frequency. I make a check to make sure the sum of these columns is this. What does the table reveal? A lot of you have skewness. I want to hear something about skewness, and I want to hear something about the direction of skewness and why looking at this. Remember to delete their direction. Don't give me the instructions, delete that and write your stuff. It's a project. Also delete this slide because I don't need the instructions. And that was project part 2. Project part 3. Directions, delete for submission. We are calculating descriptive statistics, but this is literally just instructions. I don't need this. Directions, delete for submission. I don't need this slide. Use the 35 values you created for extra credit 1. Calculate your descriptive statistics. You should know how to do that. You get your calculator, right? If you want to calculate mean, standard deviation, what do? Input your values. I suggested, and I told you guys this from before, to input your 35 values in L5. Whatever the heck they are. You know, making up numbers. I'm not going to put, because I don't want to continue to put 35 values in my calculator. So I said, put it in L5 so you're not affecting this list because you're using the other list possibly for assignments. L5 will consist of your actual sample for your project. So put it in L5. How do you determine descriptive statistics? We go to stat, calc, 1var stats. Where is my list? It's in L5. My frequency list, I don't want anything there. And I calculate my sample mean, my sample standard deviation. I have my 5-number summary. All of that is here. So not a whole lot to do. Measures of center, mean, median, mode. Your mean is given by the first one, 21. Use your proper notation. See this? Use your proper notation. Show me that you understand what you're doing. This is a sample mean. X bar is 21, whatever the heck it is. The median, what is the median? Well, if I scroll down, the median is 5. If that, well, my median. Mode, what is the most repeated value? Whatever the heck that is. You can go to your list and sort it to determine which values repeated the most. That's not a hard one. Provide at least 2 quality sentences describing which measure is best and why. Okay, I want to know something about these values. Tell me something about what they tell you. Skewness. Do they indicate skewness? These values, do they support what you said from your frequency table? If this indicated a skewness and it indicated a skewness to the right, this should support that based on these numbers. Look at the skewness. Go and review that if you need to. Why would, which measure of center would be best? Why? Is your skewness large? How much is that affecting the mean? Is it affecting the mean enough that you maybe don't want to use the mean? Or is it not affecting the mean enough that maybe you can still use the mean? Are these values close together? Why or why not? Well, if they're close together, then there might not be a lot of skew. If they're far apart, maybe there is. I don't know. You have to, obviously do a little research if you need to show what you know about this. Go back to what we did in class. 5-number summary is given in that what do you call it? In that one var stats. Minimum Q1 medium. This is just, you just put your values, IQR. Your IQR is Q3 minus Q1. Put your numbers in. What is that value? Equals, put your numbers in. You found it. I don't want this. I don't need that. Describe what the 5-number summary and IQR tell you. What I would suggest is you go back to like your box plots and stuff and determine or look at what they asked in terms of that. 50% is within that interval for the IQR. What does the 5-number summary tell you? You can include a box plot if you want to support what you're saying. I don't mind that. Do you have any outliers? I want to see how you calculate outliers. Your lower fence. My lower fence is describe it. Minimum value, not an outlier. You have to describe it. This is a project, right? This is how I calculate my outliers. I don't know why I'm choking on something. Right? Lower fence, upper fence. I'm not going to do it all. Maximum value, not an outlier. Show me the calculations. Plug in your numbers. Then, do you have any values outside of that? If so, what are they? Are they outliers? How are they affecting your distribution? What are they doing? Do they support what you said here of skewness? Do they support what you said here or here of skewness? Why or why not? Talk about it, right? Do not leave instructions. Explain why you chose these as outliers. Explain how you know. What do the outliers do? Talk about them. It's a project. Standard deviation. You have that value from one var stats. So that you would put in. Using at least 2 quality sentences, describe what the standard deviation tells you about your spread. What does the standard deviation tell you? Is it large? Is it small? Why? Does it tell you that you have a lot of variability or a little? Why or why not? Explain why. You have to explain why. Do you have about this right here? I want to see your calculations for values that are within 1 standard deviation away from the mean. I want to see value that is 1 standard deviation below the mean. Like, don't do the minimum. Show me like you understand stuff. So X bar minus S is equal to. What about 1 standard deviation above the mean? Right? Is equal to X bar plus S. What is that value? And then how many numbers are in that interval? So from here to here represents the location, the values that are 1 standard deviation away from the mean. How many of yours are in that range? And then, what is your percentage that are in that range? 88% of your values are within 1 standard deviation of the mean. What does that tell you? Can you compare that to the empirical rule that has normal distribution that says that 68% are within? Does that indicate anything about your distribution? What does it say? And that would be project part 4. So I did go through that a little faster because I did do this also in the videos. But that's the idea. You can also rewind this if you need to.